Welcome back. In this session, we will learn how to use the different features of Python. We have learned to solve problems. So we have learned so far the variables, the operators, the conditionals, the loops, and the list. Yeah. And at the same time, actually, now we learn also set. There's this set because we use this feature to learn to solve some problem. It doesn't have much stuff to learn, but we may also learn this at the same time because it might be difficult to solve the problem we are trying to solve right now. What kind of problem are we trying to solve right now is actually to count some words, lexical variety of a word, the most frequent word, something like that. As you can see, this is a speech, a text that has been taken from Michelle Obama's speech. So let's just copy this by doing this like this or copying this. You can get this material on my 30 days of Python and you go to the data and then you will get that. Okay, let's take this exercise. .py. And then, of course, I have to declare this, maybe speech or some text, something like this. And then whenever you have a big text, this would be better, yeah, to make a string. So as you can see, this is actually a string now. So just you can start step by step. You don't need this extra space. You can also remove the extra space manually or with some programming. So this is just some extra space. I can just remove, 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 and then remove this, remove, and then this remove. Yeah. Okay. And then we will do some cleaning. As you can see, this apostrophe and this dot, and then this comma, and all this character. Do you see this? This has to be removed. So because it's not important there. It seems long, actually. Did I copy it 2 times? It seems small there, but what's wrong? I have to see. Oh, yeah. Oh, yeah. As you can see, there's something like that. Okay. Then I think we're almost there. We're almost there. Oh, yeah. It's a kind of never-ending cleaning. So we can also clean programmatically that space, but this is just so obvious. We can just remove the extra space. Great. Now let's just print this. The text. Sometimes if you want to be very precise, you may also just speech, Michelle's speech or something, but for the time being, you just, let's call it txt, some text over there. txt dot, maybe length of txt. How much is it? Oh yeah, what did you do now? I just counted the number of characters, including this space. So this doesn't mean anything. This doesn't mean anything. Just, it's not important. But how about if we remove if we split the text, txt dot split where? At any space. And what does this give us? Oh yeah, this pretty good, right? Because we just got the words at least in a form. But look at this. Do we need this? No, we don't need that. Do we need this? No, we don't need, because we are going to count them. Now, but why we care? If we count them also, it doesn't really matter. What it matters, this one, as you can see, some of the words might be without dot, some might be with America. So this is going to be counted more than 1 time. So the best way whenever you do such kind of cleaning, first remove, no, do you remember replace? Replace all the comma with nothing. And then again, replace all the dot with nothing. By the way, there's a better way to do this. To remove all the characters at once, but we didn't learn that now, so we have to do it this way. Okay, and then again, what else? Now, let's just now split. But before that, let's change everything to lower, because lowercase is good. And then split it. Now, let's see. As you can see, there was dot in here, but now there's no dot. Yeah, okay. That's good. Now we can count actually this. And it's better to store this as in words. Words. Now for word in words. Print word. Have you seen that? Let's see, study. Now, but do you see this? Yeah, we have to clean that one. Do you see this? Yes, because, and apostrophe, we don't need that, this, okay? When you deal with data science, data analysis, we're just getting closer to the data. We're studying the data. We're observing the data. This is the kind of data exploration. We're exploring it. And step by step, we just change our strategy to clean it in a better way, right? So now I think still this may need to remove, replace this, the semicolon with nothing. And maybe you replace, as you can see, I have used the replace many times, and that's not a very clean kind of, now I have to use, it's not very clean approach, I would say, but it can do the job. As you can see now, we are almost clean, but as you can see, we have colon here, and then replace the colon with nothing. Yeah. And we have number. And there's a way to remove numbers, but we don't have to. We don't care about now. Now, if I just now create new words, or maybe count, I can say, how about if I just create a kind of a dictionary, new, or maybe dictionary. I mean, we didn't learn dictionary yet, but I think if there's no better way, maybe I can just first do some kind of a list. Do you remember we learned this count? So list dot append, and then actually I can count words dot count the word. How many times does it exist? And now I'm appending it. Print list. Okay, now let's, oh yeah, have you seen some words exist how many times? Like let's just, for instance, a word 18 times, but we don't know what this word is actually. Do we know? 17 times. Okay, so list is not solving our problem. Actually, we can make list to solve our problem by creating list of list. So what was that word? At the same time, instead of just appending the number of time, the occurrence, I can also append that as in a list of list, the word and how many times it occurs. Oh yeah, I think that's pretty good now. Let me show you. So, wow, that's plenty, yeah. As you can see, as 18 times you 17 might one imagine one. Now it's all about actually sorting this in different way. Okay. Then how do we sort? Let's just use the method sort. Does it help us? Maybe. How does it sort? I mean, let's just see how sort works here. And print list. Okay. As you can see, now we have to remove this, for instance. We don't want this number 18. In our data, we have numbers. We can remove numbers and special characters. So how can we remove that? So we have to clean words now, or clean words, maybe like it could be after this, I can say clean words and then do something like that. And we do that if word dot, do you remember is alpha or something? Word alpha. If word is alpha means if it is just alpha, no numeric, or no special characters. But what is this? What's the problem here? List is not defined. Yeah, because I changed this. Okay. And now let's see what we get first. Words. As you can see, no number, no special character, no way. Yeah, now I think we're approaching almost there. But now, as you can see, it has been sorted. In what way? I think the best way to sort here, we use the method you have to use. Actually, it hasn't been sorted. No, it hasn't been sorted yet, but let's just use the sort method. Clean words, just sort and see the result. But this is not what I am planning to do. I use instead sorted. Okay, let's see. As it seems it has been sorted alphabetically, as you can see. Okay, but W should come in here. But what would be our target? We should sort them by number of occurrence. So what is that? Sorted. So sorted, and it allows
Why
us
is
to
it
pass.
repeated like the he? There's many times he 28.
What?
Why there's some words repeated there in the list, like he 28 is showing like many times in the terminal.
In the terminal?
Like you can say you many times.
This one.
Yeah, all the words. So it's showing like all the words and then the count.
What? Oh. Yeah, I think there's something that I didn't Whoa, that's very good. That's very good. Oh, yeah. Is alpha. Okay. Ah, I think we have some weird stuff. Yes. Yes. Yeah. Okay. I think there's something that I didn't.
It's because every time when it met, it counted. Because we met he for the first time, we counted it and put to the list. We
Yes.
met he the second time. Yes.
That's true. That's true. Yes. So we have to add something additional. Yeah. Okay. So what we should do actually, what we should do if word not in clean words and word is alpha. Now this fixed that problem. Thank you so much. I didn't notice that. Is it clean now? If word, not in the clean words, first we have to check it if it doesn't exist here. And then if this is also just a word that doesn't have special characters or number, right? This can solve that problem. Yeah, that's why it was too long and I didn't notice that. Great. Yeah, as you can see now, this is shorter, not too much as it used to be. Yeah. But of course, the text is plenty anyway. Do you think we solved the problem? Hello? Did we solve the problem?
I think yes.
Yes, we did solve the problem. And now what's left is actually sorting this. And we have this sorted, and we have the sorted takes actually the clean word, the lists, and then it takes key. And this key allow us lambda. You never know function even, but for now, I can just ask you just to, remember this by heart and just see how it can be solved. But when we reach to the function, you will understand this much better. So I can use this function. It takes additional function, key the lambda, and then I can say X or whatever item. And this item means this value whenever it iterates each value. So this one is the first item and this one is the second. So I access this one by index. So this is the 0 index and this is 1 index. So I can say item and then 1. What I'm saying is, hey, go to this list, and then sort by this one, by the number. So, and then actually I can say sorted items. Mosa, if I'm lucky, then I think my items have been sorted out. Let's try. Oh, yeah, but it seems a bit weird again. And I'm getting some strange data. What is this?
Because you do it with clean word. It's strange.
What's the last? And 96 times, that's okay. Lambda item. Oh, what it? Oh, wait, what's this? Clean words. I use the clean words actually, so it shouldn't be something like this. 2. Why it has been iterated that much times? But how about if I just sorted with this? Do we have another sorted item somewhere?
Maybe we need to circle 4 because it looks like that condition word not in clean words is not working for some reason.
Yeah, it seems so. Sorry guys, I have tried just a list of list and it was a bit challenging, so I changed this to a different kind of data structure, and that's actually a dictionary. Dictionary is a key and a value. So as you can see, I'm appending dictionary to this list. So the word is going to be this word, and then the count is going to be words. So in dictionary, all the time we have to use this count. I mean this quote. And then words dot count. How many times does it exist? So we have to pass that word. And now let's see what we got in our clean words. Yeah, this is the cleaned, but now we have to sort it by the count, how many times that exists. So then sorted words, and then we use the sorting built-in function. It takes actually two values, two parameters, the list, the cleaned word, the clean words, and then a kind of a function, this key, and then lambda. The lambda, the item, one of the item, that means this item or this item. And then we target the item key. If we want to sort it by the word, we can say word. And now let's see what we get. Print. As you can see, we sorted it by word now, and I'm expecting actually the first, that's something A, yeah, but I don't see so far. Do we have the same problem we had? I think we had the same problem. So if word, okay, this shouldn't work now, by the way, because we changed this already to a different data structure, and this doesn't work anymore. And actually also we have the same problem. Oh, so
perhaps we can check this is the shortest algorithm in the bottom one.
yeah, thank you, Christina, for fixing this bug. So what Christina is saying actually, we are just checking only the word, but instead she's saying that this has to be stored maybe as in, you know, the list what we are creating now, list of list, and it's better to check if this doesn't exist in this, because we don't want to repeat that. And then if it doesn't exist, we can append this list. And then after that, we can sort this. So let's do that, the sorting. The sorted built-in function take lambda. But before that, I think it would be better to check even what we have in the clean words, right? Because you never know we have anything. So as you can see, a value and this, a value and this. It's a list of list, the word, and how many times it exists. So we can actually now sort them by value. So how do we do that? Sorted, and then clean words, and comma, key, lambda, item. In the item, we are interested the second value. So I can say item 1, something like that. And then just let's print this. And it should give us actually a list. Yeah, as you can see, and has been 96 times. That's really great. So what we should do, maybe it's better to reverse this. So to reverse this, or maybe we can also use the sort, what was this? Negative indexing. So I can see from -10 to the rest, and then I will get the 10 most frequent words. Our, my, he, in, a, that, of, and the, to, and. These are the, but still, as you can see, the order is not good. So it's better to reverse this. Then I think the best way to do that is actually storing this, sorted words. And then I think after this, you can just reverse can do. And after that, again, it's good to print out, print this. Yeah, it seems good. We're in a good shape. Yeah, I think it starts from here. Yeah. Then we can take the first 10 and slice. If we take this, I think I will get the first 10. The first 10 is actually and 96 times, something like that. Yeah. If we want, we can also change this to a different data structure. But now, as you can see, we are just working on list and list related stuff. Yeah. Thank you, Christina, for fixing my bug. And next time, we will try to find how we can optimize this. Now, we have used replace many times, but there's a better and optimized way and a different way to solve the same problem. Yeah, so it means we will also work on this problem another time with a different approach.